Good evening. My name is Hiroaki Isobe, and I am an astrophysicist working in Kyoto University. And I'd like to thank organizers for inviting me to give a talk in this very interesting symposium. But actually, it was kind of a surprise for me when I was first asked to give a talk in this session, because I'm just a pure astronomer, and I have never think of seriously what could be a role of Chinese character in my field. But let me say, so I'm not talking much about Chinese character in astronomy, but instead, let me say some opinion from astronomer or natural scientists in general about whether we should keep using local languages and Chinese characters in a top science. By the way, I just found that my name in the program was quite wrong. It was written in Hiroaki, but my name is Hiroaki, so this is my correct name. I understand even though we have a very interesting talks in the symposium, I understand you are already kind of tired. So I'd like to first start with some nice pictures, which you can hopefully enjoy. This is the Chinese character, the sun, which of course comes from this symbol. This is the sun yesterday. This is an image taken by the NASA's Solar Dynamic Observatory, which is a space observatory, taking solar images in various wavelengths. And this is data taken yesterday. And you see yellow surface and some black spots. They are called sunspots. I can't help imagining that the ancient people were also watching big sunspot when at the time of sunset. Actually, it's possible. It's possible. Please do not try to look at the sun in the naked eyes, but whenever sun is very close to the horizon and it's very red, and if there is a big sunspot, maybe this is too small, but sometimes we have sunspots which is maybe 4 or 5 times larger than this one. If you have a good sight, you can see the sunspot. I don't have to say as a professional astronomer that I have seen the sun by my naked eyes, but I have an experience to see the sunspot in naked eyes in the sunset. And it's a very fantastic experience, but please do not do by yourself without special glasses. Okay, so this is sun taken by the modern telescope, but I prepare even more surprising animations of how sunspot looks like in a modern telescope. This is the solar image, again in a visible light. But now I'm showing some close look at this sunspot, which is animations taken by Hinode satellite, which is a Japanese solar observatory in space. And I hope this moves. So you are closing down to the sunspot. Here you see a sunspot, and you are getting closer and closer. And finally, you start to see very dynamic, fine structures around the sunspot. By the way, this sunspot is called a Japan sunspot from its shape. It looks like a Japanese island. So this surprising animation is taken by modern solar observatory. And you can see that as things are moving. This is this small scale motion is by thermal convection. And this dark part is called umbra, which has a very strong magnetic field. And the size of the sunspot is, well, okay, you can put maybe 7 or 8 Earths inside the sunspot. So this is a very big phenomenon. And why I show this in this symposium is a bit related to how the science has been changing our view of the world and our way of thinking. And I hope it is still changing the modern people's way of thinking and the view of the world. But before I move to that topic, first of all, I'd like to start briefly discussing whether the scientists think that we should keep using local languages in the top science level or not. The thing is that the language of natural science in a modern era is completely English. This was not true in Europe until quite recently, maybe a few decades ago. For example, the famous paper of relativistic theory by Albert Einstein was published in German. But even in Europe, nowadays, practically all the important scientific papers are published in English and not in other languages. Well, maybe this is not true in some field of science, but at least in physics and astrophysics and these fields, which I know, new discoveries and new achievements are hardly recognized if they are not presented and published in English. Of course, this can be well justified, because, particularly for astrophysics, because the subject of astrophysics is almost by definition universal. We are looking at something outside the planet. So there is no particular local features in what we are studying in the field of astrophysics. So new ideas should be or must be shared universally or globally. Otherwise, it's not considered to be a valuable ideas. And to be shared universally, we must use common language, and English is or is becoming the only practical option to share such a new concept in a worldwide. So we scientists have no choice but publish in English. This means that if we are supposed to do some scientific activity in our own languages, which means that we, outside the non-English, in a non-English speaking country, have to pay additional effort to sustain such activity using our own language. So I just asked some of my colleagues, including those in Korea and China, whether they think that they should use Chinese characters or their own language in top sciences. Many of them say, okay, my question was, is there no point in using Chinese character and our own language in sciences? And many of them say, certainly no, we should use Chinese characters and our own languages in science as well. And what they say is, first of all, in their daily science activity, for them, it is more effective to discuss in their mother tongue rather than discussing English. So this is a practical reason. The others say, the new discovery and achievement must be published in English at first, but these scientific results should be shared with public because they are the sponsor. We are, unfortunately, there are very few businessmen or rich men who are willing to pay for astronomy because it doesn't make any money. So we are supported by taxpayers. So this means that what we learn in astronomy must be shared by the public. Otherwise, we don't get support. The public, most of the people, they don't speak English or they are not happy in being forced to read English just to learn science. So we have to use Chinese characters and we have to use our own languages. Some of my colleagues say maybe we can shift most of the scientific activity into English because in any way we need to publish in English. They don't want to pay additional effort to repeat the same things once in English and again in other languages. This is one reason. The other reason is that, for example, in Kyoto University, we want to attract talent internationally. We want to attract talent. As a researcher, we want to attract good students internationally. And for this purpose, if this scientific activity or educations are going on in English, That's quite an advantage. So maybe there is a reason to shift our language into more and more English when it comes to science. Some people say that. But when we say scientific activity, there are different levels. So we have to clarify a little bit what I mean by scientific activity. Of course, there is presentation and publishment of top scientific results. Most of the people agree that at least next 100 years or so, we have to use English. There's no choice for that. In the other extreme, the bottom item, the public outreach is important, as I said, to get support from the public, from taxpayer. And of course, we have to teach the children and students the new science in elementary school or high school. The education in such level, maybe some people may say that they can also do that in English or other languages, but practically we still have to use local language. So for the last item, we have almost no choice but use local language. The two items in between, there might be a choices. One is daily research activities. So what we do in the lab in every day. What I do in every day in lab is I don't use a telescope, but instead I downloaded the data from satellite and analyze and discuss with my colleagues and what it means and these things. Or some people do experiment, some people do calculations. These activities can be done in English. Actually, in Kyoto University's observatory, which I'm working in, we have a few students from Europe and one person from India. And when we are collaborating with these people, of course, naturally, we have to use English. So, of course, you have to use English or any other common language if there are international collaboration in it. But if only a local people, or for example here, Japanese-speaking people are working there, what is the point in using English? More serious item is the third one, the education in graduate and undergraduate levels. Actually, there is a kind of increasing pressure that this university education must provide at least option in English. So we are asked to give a lecture in English, we are asked to give a series of seminars in English to attract the students from international community. And I think this makes sense. But on the other hand, if all the university education was done in English and no top-level science education in our own language, this means that okay, for the last one, we use local language, but the first three items in which the real top-level scientific activities are going on, and if all these things are done in English, this means that practically we lose top sciences from our own local languages. And this may or may not have a significant influence in the future of our culture and society. So from now, I would like to move on some discussion on what astronomy, which is my field, have been providing people the way of thinking, the view of the world, and what it is or it will be providing to the society in a long-term future. By the way, Dr. Matsumoto and Professor Taketo talk about how scientific terminology have been integrated into the Chinese character culture. Actually, new new terms are created. New terms are created means that new concepts are kind of imported into our languages. Particularly in Japan, not only this terminology, but also many textbooks has been translated into Japanese, or even a textbook of the top scientific level has been written. For example, this is a famous physics textbook by Randall Lifshitz. This is a classical theory of field. This is widely written, widely read in most of the physics students in the world. The Japanese people have been paid a lot of effort to translate most of these important textbooks into our own languages. And also, this is a textbook on space vessel. This is a new field. I am one of the authors of this textbook, and this is certainly a textbook for the graduate student and expert of this field. So this includes top-level science, and we are still writing, or we are still paying a significant effort to publish these things in our own languages. And we do this because this certainly helps to at least bottom up the scientific level of students in general, and as well as the professional engineers and technicians, if not top scientists. So, practically, we know that keeping scientific activity in our language at least have some merit. But of course, it has some, it has pros and cons. And cons is that we have to pay additional effort, even though we are under very heavy competition within the international scientific community. But so in order to just survive, for individual scientists, in order to just survive this very tough international competition in the scientific world, actually, we don't have to use local languages. We just focus on our activity in English and keep publishing in English. This is the way for individual scientists to survive. However, we still believe that in long term, it makes sense for our own society that we keep scientific activity, not in English only, but also in our own languages. So let me say, just in my field, which is astronomy, what does astrophysics, or astronomy, means for humankind? People say, we say, astronomers say, that the ultimate reason that we explore and study the universe, or astrophysics, can be summarized by the title of this famous paintings by Paul Gauguin, which is stored in the Boston Museum of Fine Arts. The title of this famous picture is, why do, I think this is where? I'm sorry. Where do we come from? What are we and where are we going? I think I put why because there is an option that why are we here? But this is another version of the three titles. I think the correct title of the painting itself is where do we come from, what are we, and where are we going? And this is the questions which Paul Gauguin asked for himself, but this is a question that we astronomers are pursuing in our scientific activity. And actually, this is not a question only for some artists and some scientists. This has been a question for humankind in their long history. In ancient time, in a time of myth, people describe the world in their own way. Like this is, for example, this is a famous Indian picture of the world, in which, I mean, our land is located on the top of the back of the camels, which is supported by a snake, something like that. Of course, this is not correct from the modern scientific point of view, but this is the way people in the time understand the structure in the universe. By imagining this kind of picture, they try to understand, or they try to convince themselves that why they are there. And by doing so, they obtain the relief of their mind. And this is the function that the myths and some of the religions are playing in ancient time. And this is well related to our modern activity in the field of astrophysics. In more recent time, say 300-400 years ago, driven by the curiosity invoked by the astronomical observation of the motion of the stars, people start to realize that, hey, there is something like gravity. There is something like some law of physics that governs both stars and motion of this cap. The motion of this cap and motion of the stars are governed by the same law of physics. This was a kind of very big surprise and very big discovery of humankind, because this opened the way of thinking that in this turtle's world, the world can be understood only through imagination or communication with some translational beings like a god. But from careful observation of the motion of stars, people start to realize that the world is something which they can understand and explore by their own reason. And this has a significant achievement for the humankind. Okay, this was historical things. So what is modern science or modern, say, space exploration is providing for us now? What is that giving it to us? Some people say that the most important achievement by the modern space exploration can be summarized by this picture. This is, of course, you know what it is. This is a picture of the Earth taken by one of the Apollo project. My father told me that before Apollo got this picture, you know, this, in school you have some model of those. They are painted in a brown color because people think that the land is brown. So the people think that land is brown. Maybe some old people can correct me if I'm wrong. It was only after the Gagarin saw the Earth from the space, and only after the Apollo took this picture, people realized that the Earth is blue. No, people, maybe they knew, but they got a very, very deep impression that Earth is blue and beautiful and very precious, and shared by the older people on this planet. This has a significant impact on the way of thinking of the people. And the important thing is that the space exploration in 20th centuries was kind of contemporary with the development of the TVs and mass media, and in recent years, internet. This means that once these new pictures were taken, it can be shared almost simultaneously with the people's world. And since this picture is now widely shared by the public across this planet, when we hear the words such as spaceship Earth, or we have to protect our environment, we are cosmopolitan. There is no border on the Earth. When we hear such concept, we immediately understand what it means. And this is now this is so easy to understand what this word means, because the science and technology provide people this picture of the Earth. This is one of the good example that how the scientific achievement can change the way of thinking of the people. So, short summary, science is still one of the most important drivers that change and calibrate our way of life and our way of thinking. So, if it is lost from our own languages, if it is lost from our own daily activity, and if this top science is only going in English in a scientific community, we may be losing some important part of the culture in a long-term futures. So, in last few minutes, I want to say something about future. By the way, this is our future. Our future looks like this. This is a called planetary nebula, but practically this is a dying star. After 5-6 billion years, our sun will become like this. And if our ancestors still want to survive at that time, we have to escape into other stars. And why do I show this? Because I want to discuss future. This is the sun and world people are seeing in 10,000 years ago. This is the sun we are seeing now. This is part of the sun. You see there's a big explosion called solar flares occurs here. Explosion occurs here. And this explosion provides lots of high energy particles, radiation particles, and the gas and money field into interplanetary space. And if the one astronaut outside the spaceship at that time, he will die because of radiation. This will 4 to 5 Siebel radiation from solar flares. If this is an animation produced by NASA, that if such explosion on the sun occurs, what influence it has on the Earth. So you have an explosion on the sun, and this gas and radiations are traveling into the interplanetary space, and it collides with the sun, the Earth's magnetic field, producing an aurora. Aurora is good things, but it also aurora is good because it's beautiful, but it has also some bad things like it damages the satellites, and it has some it caused some problem in satellite communication and so on. So we are actually living near the variable star. Sun has been a kind of a symbol for constant things, but we now know that sun is variable and the Earth is variable. Oh, by the way, this is also another picture of our future. The thing is that 1 in 100 million years, our continent will get together and separate. So we say our land, we have border, natural borders on our modern planets. But if you look at the future, long future, which is, say, tens of millions ahead, the shape of the continent and shape of the island will be completely different. So sun is changing, the Earth is changing. Sun's climate is also changing. The global warming is one of the most significant problems in our modern society. But if you look at the long-term future, which is not very long actually in astronomical sense, it's just 100 10,000 years, or maybe 10,000 years future, the temperature of the Earth will be, say, 10 degrees different. So things are changing. We know that our star is variable, environment is changing, and we even know more seriously that our society is also very, very variable. And in order to survive changes and adapt to changes, we need diversity. This is what we know now. If we don't have diversity, in a general sense, we cannot survive the changes. Diversity is important. Is this diversity, globalization, cosmopolitan, spaceship growth, is this diversity we are obtaining? No, this is more unification. This picture was good because now we can, because of this picture, we can share that this Earth is very precious things we have to attack to the global problem in collaboration with the people within the world. But this is a way to unification. This is a way to globalization. This is not a way to diversity. So what we can do? What we can do to keep diversity in our society and also in sciences? I was kind of very impressed when Professor Liu say in his talk in the morning that people today still can read and understand the official script 2,000 years ago. Yeah, I think so. I think that, okay, then Chinese character could be an important option to hand down our current knowledge and way of thinking, including scientific results, to generations 1,000 or 10,000 years later. So, and 1,000 years is very in a focus. In actually almost 1,000 years, there was an event called, I have some strange script here. There was an event called supernova, which is recorded only in East Asian literatures, like Megetsuki in Japan. Oops. Such supernova explosion 1,000 years ago is still have a remnant in our modern sky. And recently, Professor Katsuji Koyama, who is an excellent astronomer in our university, observed the event 1,000 years ago by modern telescope. And because there was a record 1,000 years ago in Chinese and Japanese literature, we could calculate exactly what was the energy of the explosion, etc. This means that because of the people 1,000 years ago, we could produce new scientific achievement, new scientific discovery. So this was a kind of top-level science results by collaboration with people in 1,000 years ago. And Chinese culture of Chinese character can have the potential to keep doing this kind of things in next 1,000 years. I'm running out of time, sorry. So to summarize, the natural science such as astronomy and physics have been changing our view of the world, and that's our way of thinking. So we definitely need to keep integrating the science to our own language and culture. And East Asian culture of Chinese characters has the potential to provide a healthy diversity in the field of top-level sciences. This is important not only for ourselves, this is important for humankind in this planet in 1,000 years' time or even in a long-term future. So we should do that. So my suggestion is that we natural scientists alone cannot manage to keep doing scientist activity at the same time integrating it to our own culture and own languages. So we definitely need close collaboration with scholars and artists and various people from various fields. And I think this association of East Asian Research University could be an ideal platform for this sort of collaboration. Thank you for listening.